In this video, we are going to create our first particle simulation, and we are going to make this. It's a simulation you're watching now playing live. It has around 50,000 particles. We get that nice turbulent emission, things slow down, and all these particles are cloning little cubes using a cloner. And I'm going to show you how you can do this. It is fairly simple. So let's go to a new project and start with what I promised, a basic emitter. Just click on this and you will see in the object manager that not only we have a basic emitter, but we actually have what's called a particle group. Now, let me explain a few things about this particle group. Although the basic emitter is green and implies it being a generator, in fact, the generated particles exist in the particle group. And if I just press play here, you see a bunch of particles emitting, and these particles exist over here where it says particle group. Let's go and change a few things about the emitter. First of all, when you have the basic emitter, in the emission tab, it gives you an option of what shape you want to emit from. And these are the four options: a rectangle, a circle, which are flat, two-dimensional, and a cube and a sphere. I'm going to go for a sphere, and you can change the dimensions here, 20 by 20 by 20, and you can see it's small. Another thing you may have observed is that I'm changing parameters, but the simulation doesn't change. That is because this is an actual simulation, which means that things are not live. It's only live when it's playing in the timeline. So always rewind and press play to see the simulation in action. You can stop at any moment. And you can see that now the particles are going in a radial direction. Those things are controlled in the properties, which we are going to see in great detail later on. But for now, this looks good enough for us to proceed. Now, I want more particles. So I'm going to go down here, again in the emission tab, and we have emission modes. And here it says constant, so it's going to constantly emit a certain number of particles, either per frame or per second. And I want to set this to be 10,000 per second. And again, I'm going to go and rewind, press play, and we can see many more particles. Excellent. Now, this is not bad, but I want to do something with these particles. I want to make them a bit more interesting. So first of all, let me extend my timeline to 200 frames. And the next thing I'm going to do is just go to the simulate menu, and from my standard forces, the ones we've been using with the other particle systems and with simulations, and I'm going to go and grab a turbulence. I'm going to change a few settings here, and I'm going to set my turbulence to 25 strength, 50 scale, and 50 frequency. Again, we're going to see exactly what the frequency and the scale does as we move on with our tutorials. Let's rewind and press play again. And now we see this interesting turbulent motion. Not bad at all. Now I can always zoom out and you can see that the particles are going on and on and on. And that's what they're going to do. Because by definition, particle has a lifetime, as we call it, of 0 frames, which means infinite lifetime. As long as there's animation to play, the particle is going to exist and do what it has to do. More on that later. Back to the emission. What I want to do now over here is I want to introduce a bit of slowdown. You can see that this is expanding. I'm going to go back close. And I want to introduce a way to slow these down after a certain amount of time. And the way I'm going to do that is by introducing another of my forces called the friction. Now, I can set the friction to a very high number, and now we're going to get the effect of both these forces. The friction is trying to slow them down, the turbulence is trying to push them around, and we get these conflicting forces, although the result doesn't look that bad. I can sell this to someone and charge them 8 hours of work, but I'm not going to do that. Instead, I'm going to do the following. Let me turn off this friction and press play. I want to go to a certain time frame, and at that time frame, I want to reduce the strength of my turbulence while increasing the strength of my friction. So I'm going to stop that competition between the forces, and I'm going to art direct it. And I'm not going to use any specialized tools. I'm just going to change the keyframe values. So I found some interesting numbers that if I go, for example, to frame 100, and one thing you will see is that when you're scrubbing, the simulation doesn't play. And again, that's because it has to play live on the GPU in order for it to do its thing. Later on, we're going to talk about caching the animation, and that will allow you to view it and scrub and do all sorts of things, but it will have all its parameters fixed. More on that later. This is going to be my catchphrase from now on. More on that later, because we have a ton of stuff to talk about. So I'm just going to go to frame 100, and I'm going to go to this turbulence force, and I'm going to add a keyframe. At frame 140, I'm going to set this to 0. So after frame 140, the turbulence is not going to apply anything. Now, what we'll see before we touch anything else, we're not going to activate the friction yet. What you will see is that although the turbulence will turn down to 0, the particles will not stop. All they will do, and if I extend my timeline, you will see it even better, is that they will continue going in a straight line. They're not going to change their directions anymore, which is pretty much what the turbulence tells them to do. So now I'm going to go to the same keyframes at frame 100. I'm going to activate my friction, and I'm going to set it to 0 at frame 100. And at frame 140, right here, I'm going to set my friction to 50. And these are just numbers I found by playing around. You will art direct it in this way. Again, I'm going to set this to 200. I just wanted to show you that they go in a straight line. And I'm going to rewind, press play, and this is what you're going to see. We see our simulation, then suddenly the turbulence stops, and we have this very, very slight motion. And this motion is because the friction doesn't freeze them, it just slows them down more and more, but there's always a bit of motion. And you can see it plays all the way to the end, and we have this interesting result. Now, there's one more thing I want to do, because if you go close to your emitter, you will see that we're still emitting particles, right? And again, I'm going to do these extensions of the timeline quite a bit. Now, you can see that it's emitting particles nicely, and then they freeze, but at the center, it's pumping out more and more particles, but they can't move very far because the friction is quite high. What I want to tell my emitter is to stop emitting at frame 150. That's it. And although we could go and keyframe the rate and all that, actually there's a mode here. If you click on range, this means that it will use a frame range in order to emit these particles. The start frame is always here, so you can offset this if you want your simulation to start at a later frame. And the range tells you for how many frames you want it to emit from the start frame. I'm going to leave it at 0, and I'm going to set my duration to 150. So what I'm telling my emitter now is that I want to start emitting 10,000 particles per second at frame 0 constantly, and at frame 150 I want you to stop emitting, and that's it. So rewind, press play, and you will see that it's going to emit particles, and at frame 150 it's going to stop. That's it. No more particles are generated, and we have this nice little growing sphere. So let me zoom out here and frame it. I'm pretending I'm a director now. Fix it in post. No, did I really say that? So let's press play, and you can see that we have our little simulation here, and it looks beautiful. It's very fast. It has quite a few particles. The last part of this is to clone something on these particles. Now, you can directly render these. There's absolutely no problem whatsoever. Let me just bring up Redshift, and if you start the render view, you get particles with the color they've been generated in, and that's all nice and fine. This is just the automatic way to render particles in Redshift, but I want to go and assign objects to them. So let me go back to my particle layout. I will do that using a cloner. So create a cloner, let's make a little cube because I want to clone cubes, and I'm going to make my cube 2 by 2 by 2, nice and small. Made a child of the cloner, and now you tell the cloner to go to object mode. And the object you need to use, and that's very important, is not the emitter. No, not the emitter. It's the particle group. This is the object that contains all the particles, the points, and all the data associated to it. The emitter only gives a number of instructions on how these particles are going to be generated, when, how big they're going to be, and all that nice stuff. But the particle group is what holds the actual data. Our particle object is the particle group. So I'm going to grab this and put it over here. And I can even make my particle group invisible. And I'm going to go here, and you will see we have a lot of cubes. Now you can see it's stuttering a bit, and that's because I'm using the instance mode. It's actually cloning over 10,000 little cubes, but I can always switch to multi-instances, and now things are going to be blazingly fast. We can render millions of cubes using this method. But in any case, you can go here, you can change the sizes, you can do whatever you want and create beautiful graphics. And this was the most basic type of particle simulation you can do. As we move on to the other tutorials, I'm going to start introducing more objects, more parameters, and more ways to work with particles.